Algebra 2 Honors Lesson 14.1, Verifying Trig Identities and Simplifying Trig Identities. So let's take a look at the first few trig identities. The reciprocal identities, okay? We know that cosecant and sine are inverses, so cosecant is equal to 1 over sine. Secant and cosine are inverses, so secant is equal to 1 over cosine, okay? And cotangent and tangent are inverses, so cotangent is equal to 1 over tangent, okay? By definition, we already know that tangent is equal to sine over cosine, okay? We get this from right triangles in the unit circle. So tangent is equal to sine over cosine. So since cotangent is the inverse of tangent, we're just flipping this right here. So cotangent is equal to cosine over sine, all right? So one thing you need to understand about these trig identities, we know that tangent theta is equal to sine theta over cosine theta. So let's say you're given tangent squared theta, okay, tangent squared theta. Well, since tangent is being squared, that means you can also square these values right here, okay? So let's say we had, let's say for example, cotangent cube theta. If you want to, this is equivalent to 1 over tangent cube theta, okay? So for these trig identities here, it's okay for you to do that, all right? And you understand what I mean when we start verifying identities, all right? Moving on to the next one, the Pythagorean identities, okay? These are very important, all right? So the main identities are these three right here, okay, in bold. And then to get these other identities, all you're really doing is, let's say you want to get sine squared, right, by itself, you would minus cosine squared on both sides, right? So you minus cosine squared, right, on both sides. So this is gone, so sine squared, once it's by itself, is equal to 1 minus cosine squared. That's how you get these 4 over here. All you're really doing is you're isolating, you're picking, right, a term to isolate, okay? So from this, we're able to derive these 4 using algebra manipulation, okay? And then you're doing the same thing here, so tangent, right, tangent squared plus 1 is equal to secant squared. Through algebra manipulation, we're able to get these also, all right? And it's not important for you to, you don't really need to know why these are the way they are. I could show you with a unit circle why sine squared plus cosine squared is equal to 1. Basically, it's just the Pythagorean theorem, okay? But what's important is you need to remember these and know how to apply them when it comes to verifying, okay, and simplifying. And one thing to keep in mind that's very important, by definition, sine squared plus cosine squared is equal to 1, okay? So these values must be squared. So if you just see sine plus cosine, okay, I'm just not writing the x or the theta, whatever they use, right? This is not equivalent, all right, to 1, okay? So this is not equal 1. These values must be squared, right? For the Pythagorean identities, all right, these values here, these terms must be squared accordingly, okay? So you always want to have these, copy these down and keep these reference. You're going to need these when we are verifying, okay? And the most important one that occurs the most that you should recognize all the time is this one. Sine squared plus cosine squared. And anytime you see that, you should know that, oh, that equals 1, okay? And you'll see in a moment. So before we start verifying, here are some guidelines when it comes to verifying, okay? So keep in mind, when you guys are verifying a trig identity, you can use any concept, idea that you've learned in math to try and verify and work out the problems. Meaning, you might factor, you might FOIL, you might, take out a GCF. You might see a difference of squares, right? You might have to multiply top and bottom by the conjugate. Okay, so all those concepts and terms and skills that you've learned prior, you have to recognize them when the situation arises, and you have to know that, oh, I need to apply it in this situation. Okay, so keep that in mind. So let's take a look at an example here, our first example. So we are asked to verify, this identity right here. So when you are verifying, what you are doing is you'll be given something, and you have to prove that the left side and the right side are equal. Okay, so you have to pick a side to work with. Sometimes it's more obvious than others. Like in this case, obviously you're going to work with the left side, and you're going to somehow try and prove that it equals the right side. Okay, but sometimes both sides look pretty complicated, so you have to kind of decide which side do I work with. So the first step is to decide which side to work with, and I recommend working with the side that kind of has more terms or looks more complicated, has more stuff. Okay. So for this problem, I'm going to work with the left side, right? So you pick one side and you just work with that side, and you try and make it equal to the right side. All right. So what you're going to do is, next step, after you pick a side, you want to change everything to sine and cosines. Okay. Sometimes you could substitute in some values from your Pythagorean identities, right? But your best bet is always to change everything to sine and cosine. Okay. So I'll have 1 here plus tangent squared, I know, is sine squared over cosine squared. You could write the theta if you want. It doesn't really make a difference to me. Or you could just work it out and then put the theta in your answer at the end. That way you don't have to write it every single time. Okay, just understand that it's there, and it represents an arbitrary angle, right? So I've changed this tangent squared to sine squared over cosine squared. And then right here, what you're going to do next is you're going to, well, it looks like we've got fractions and we're adding them, so we need to get a common denominator. So our common denominator here is going to be cosine squared. Cosine squared. So you have to multiply top and bottom, right? It's just like, going back to, when you need to add fractions when you first learn them. So you end up with cosine squared plus sine squared over cosine squared. And then here's where you need to recognize, oh, cosine squared plus sine squared, this right here, right, from our Pythagorean identities, this is really just 1. Okay, then over cosine squared. So 1 over cosine squared, well, what's the inverse of cosine squared? That's secant squared. Okay, and that's exactly what we're trying to prove. We're trying to prove that, alright, this left side is equal to secant squared, which we've just done. Okay, so your last step, right, the left side and the right side should be exactly the same. Okay, if you're doing everything correctly. And make sure you show all your work step by step and work vertically going down. Okay, I kind of ran out of space here, that's why I kind of went to the side, but work vertically going down so I'll understand step by step, and I'll understand your logic and your reasoning for each step. Okay, in order to get credit, you need to make sure all the steps are there. All right, and another thing to keep in mind, a lot of times there's more than one way to do these problems sometimes. Okay, so you might do it one way, your friend might do it one way, but if you're all doing, using the correct steps and everything and logic, you can still come to the same answer, all right, with different methods. All right, let's take a look at another one. Verifying identities. Second example. Now this one, right, so you have to pick a side to work with. Now both of them look pretty similar. Okay, so which side should you work with? In my personal opinion, I believe it's easier to take things that are being added or subtracted and end up turning them into multiplication. I think that's a lot easier than taking multiplication and then trying to somehow convert it into adding or subtracting. So I would work with the left side here. Okay, so once I've chosen a side, I'm going to change everything to sine and cosines. Okay, so tangent squared, we've got sine squared over cosine squared minus sine squared. So let's put that over 1. In order to subtract the fractions, we need to get a common denominator. In this case, it would be cosine squared. So then that is going to give us sine squared minus sine squared times cosine squared, right? All over cosine squared. And from this step here, you should recognize that, I could factor out a sine squared because both of these have sine squared in common. So there's a GCF sine squared. One common mistake that I'll see is students might cancel this cosine with this cosine. You cannot do that because this is one whole term up here. Okay, this is one whole term. So be careful there. Okay, I know these two are multiplying, right? But this is one whole term because this term is being connected with this term here. Okay, so I'm going to factor out a sine squared. So that's going to leave me with 1 minus cosine squared over cosine squared. Let me get some space here. And then now, 1 minus cosine squared, if you look on your Pythagorean Identities chart, this is sine squared, right? This right here is sine squared. So I'm going to have sine squared times sine squared over cosine squared. And then next thing, you should recognize right here, sine squared over cosine squared, that gives me tangent squared. And then you have the sine squared here, and they're multiplying, and I believe that is what we are trying to prove. We're trying to prove tangent squared times sine squared. So that's what we've done, tangent squared times sine squared. And then you can put in the theta if you like, that's fine. So tangent squared times sine squared. Okay. Something I want to point out. So here when we have sine squared times sine squared over cosine, right? So these are multiplying with each other right here, the two sines, and then you have the cosine. So if I group this right here, the cosine squared only goes with one of these, right? This can be similar to, let's say we have this. Let's say we had sine squared plus sine squared over, it doesn't have to be sine squared, it could be something else, but let's say we have two separate terms being added over cosine squared. This can also be written sine squared over cosine squared plus sine squared over cosine squared. Okay, so right here the denominator goes to both of these because these terms were being added. So anytime two terms are being added or subtracted, you can, when you're separating it, the denominator will go to both. But if they're being multiplied, the denominator basically, it could go to, either one but not both. Okay, so only one of them. All right. All right, let's take a look at the next problem. So we need to verify this. All right. So once again, I believe it's easier to take adding or subtracting and then end up with multiplying at the end. Okay. So right here, it looks like, let's change stuff to sine and cosines. So tangent, all right, notice is not being squared, so this is only going to be sine over cosine plus cotangent, we know is going to be cosine over sine. So in order to get common denominator here, we're going to multiply by sine. Over here is going to be cosine. Right? Because our common denominator is going to be sine times cosine. So sine times sine is sine squared. Right? You could put the theta, it doesn't make a difference. Cosine times cosine is cosine squared. And we know this right here, right? Very common, this equals 1. So 1 over sine times cosine. So this right here, we separated 1 over sine times 1 over cosine. Well, what does that give us? 1 over sine, Alright, that gives me cosecant. 1 over cosine gives me secant. And that's exactly what we're trying to prove, right? Secant times cosecant. Right? You could put in the theta if you like. Let's take a look at this one right here. So obviously we're going to work on the left side here. And the only thing that we can change is tangent squared right here. Okay. Now a common mistake, let me point out. 1 minus cosine squared, right here. I've seen some students try and change this right here to sine squared. Because yes, 1 minus cosine squared is sine squared. Okay. Well, let me include this x part too. But you need to be careful because this is not its own term. If they had put this in parentheses, then yes, you could do that. But you cannot do that here. That would be algebraically, mathematically incorrect because we have 1 minus and then you have to take, you're multiplying these two to get some arbitrary term here. Okay? So you can't change this to sine squared, so be careful. Over here, tangent squared, you could convert that. So we have 1 minus cosine squared. Tangent squared we know is sine squared over cosine squared, right? And then since these two are multiplying, the cosine squares cancel out, so we end up with 1 minus sine squared, which then we know is cosine squared from our Pythagorean identity. Okay, so this one wasn't too bad. Let's take a look at the next one. Over here, looks like we're going to need to distribute, right? So that's going to give us cosine times secant minus cosine squared. Well, cosine times secant, secant we know is 1 over cosine. So these divide out, so we end up with 1 minus cosine squared. 1 minus cosine squared we know is sine squared from our Pythagorean identity. Okay. So some of these could be really easy. Okay. Some of them could be very, very difficult and lengthy. It just depends. We'll do some pretty challenging ones in a moment. Over here, it looks like, oh, we're gonna need to FOIL, right? Like all the algebra skills that you've learned in the past, you're gonna have to apply them to these problems. All right. And what verifying does is it teaches you to recognize situations, and it improves your algebra 2, foundation and skills, because those have to be very strong for AP Calculus. 1 times 1 is 1. So you multiply here, that'll give you positive sine. You multiply here, that'll give you negative sine. You multiply here, that'll give you negative sine squared. So these two cancel each other out. So you end up with 1 minus sine squared, which we know is cosine squared. Okay? So it wasn't too bad, right? The important thing is when you see something like this, you know that you need to FOIL this, okay? It's just like anything else you've seen in the past. Like when you saw this in the past, you know that, oh, I need to FOIL this, right? Now it's the same thing. It's just that you're seeing trig values in the binomials. Let's take a look at this problem right here. So obviously I would work with the left side. It's easier to take this and end up with multiplication. So I'm gonna work out the numerator right here. So I'm gonna change tangent squared to sine squared over cosine squared, and then we have plus 1. So I'm gonna need to get common denominator. I'll multiply top and bottom by cosine squared. So that's going to end up giving me sine squared plus cosine squared over cosine squared. And then I know sine squared plus cosine squared is 1, right? From our Pythagorean identity. Right, so this is the numerator right here. I worked all this out. This is what I have on top here, once simplified. Let me work out the denominator over here. So I have cosecant squared, so that's 1 over sine squared, right? Minus 1. So I'll get common denominator, multiply top and bottom by sine squared. So then that gives me 1 minus sine squared over sine squared. And 1 minus sine squared, okay, 1 minus sine squared I know is cosine squared. So this is going to be cosine squared over sine squared. Right. So this is our denominator right here, right? Let me just write that over here. Cosine squared over sine squared. So then what I'm going to do now, I'm going to take the numerator and multiply by the reciprocal of the denominator. So 1 over cosine squared times the reciprocal of this, sine squared over cosine squared. Right? So 1 over cosine squared, alright, that's secant squared, which is what we're trying to prove right here. Times sine squared over cosine squared is tangent squared, right? So we've proven secant, alright, squared times tangent squared. Right? So we've got what we were trying to prove. Okay. Now this is kind of a long way to do it. Like I told you, there's more than one way to do these problems sometimes. Okay. So right here, another way to do it. If you take a look at your Pythagorean identity chart, this right here, right, this is secant squared right here. Right, this is secant squared right here. This right here is cotangent squared. Okay. Well, we have secant squared. Let's say cotangent, you change it to, remember cotangent, this can be written, I'll show you even 2 different ways to do it. So you can make this secant squared times, alright, 1 over cotangent squared, which we know is, alright, tangent squared. And then we're done, right? We're done. Or you could have taken this, let's say you didn't separate it this way. You know that cotangent squared, right? That's cosine. That's cosine squared over sine squared. And then you can multiply by the reciprocal. Secant squared times reciprocal of this. Sine squared over cosine squared, which we know is tangent squared. So once again, we get what we needed to prove. Okay? So like I said, there's more than different ways to do these problems. So you could do it one way, as long as all your logic and reasoning and your algebraic steps are correct. You can get the answer, right, along with your friend who may be doing it differently. But if they're doing it correctly, they would arrive at the same answer also. Let's take a look at one last verifying one. Okay, so I'm going to work with the left side because it's always easier to end up with multiplication, in my opinion. So I have sine minus, alright, cosecant is 1 over sine. So if I get common denominator here, I need to multiply top and bottom by sine and sine, right? So I'm going to end up with sine squared minus 1 over sine. And then here's where you have to be careful. Sine squared minus 1, if you take a look at your identities, this is actually going to be negative, alright, cosine squared. Okay, it's a negative cosine squared over sine. Okay, negative cosine squared over sine. And then negative cosine squared, well, that's really just negative cosine, right, times cosine, because negative cosine times cosine gives you negative cosine squared, right? And then we have a sine underneath one of these, right? So what's cosine over sine? Well, that's cotangent. So we have a negative cotangent, right? This right here is cotangent, right? And then you have the negative times cosine. And that's exactly what we were trying to prove. Okay. Now let's take a look at some of the, so that's verifying. Now let's talk about simplifying. Simplifying is actually really, really easy. Basically, you're doing the same thing, but you don't have to prove a specific, a specific expression at the end. So we have cosecant here times tangent. So all you're doing is just change everything to sine and cosines and simplify as much as you can, and then whatever you're left with, that's your answer. So I know cosecant is 1 over sine. I know tangent is sine over cosine. And since they're multiplying, well, the sines you can divide out. So you end up with 1 over cosine, which we all know is, the inverse of secant. And that would be your answer. Right? 1 over cosine is secant. Okay? And then whatever value you're left with at the end, that's your answer. Okay? Let's do a few more simplifying ones just so you get used to it, but these are actually pretty easy. So let's take a look at 1 minus secant squared. Well, that gives us secant squared. That's 1 over cosine squared, right? 1 over cosine squared. So let's get common denominator. Multiply top and bottom by cosine squared. So you end up with cosine squared minus 1, right, over cosine squared. Right, so cosine squared minus 1 over cosine squared. Now, if you remember back from our Pythagorean identity, remember sine squared plus cosine squared is equal to 1, right? So we have a positive cosine squared here, minus 1. So what you're really doing is you minus 1 here, you minus sine squared here, minus sine squared here. So that's gone, You end up with cosine squared minus 1 is equal to negative sine squared. So this right here is equal to negative sine squared, right? So you can substitute that as negative sine squared over cosine squared. And then sine squared over cosine squared, this part right here, we know that's tangent squared. And you have the negative right here. Okay? So I'm just showing the work for this right here. Initially, when I gave you the Pythagorean identities, I gave you the original, I gave you this Pythagorean identity, and also all the 4 manipulated ones that you can get from, algebra derivation, right? Let's take a look at how about this one right here. So, well, secant I know is 1 over cosine. Tangent I know is sine over cosine. So if I were to take this, work it out, that's 1 over cosine times the reciprocal of this, cosine over sine. Well, these divide out since we're multiplying. So 1 over sine is equal to cosecant. Okay, and then you can put a theta at the end with your answer if you want. I mean, I don't make a big deal of that. Let's try a few of these. How about this one right here? Cosecant squared, I know that's 1 over sine squared. Minus cotangent squared, I know is cosine squared over sine squared. And we've got common denominator, so let's combine, simplify the top. 1 minus cosine squared over sine squared. I know 1 minus cosine squared is sine squared. So sine squared over sine squared, well, our answer is positive 1. Okay? And then, let's see. Let's do one last one right here. So we've got cosine times cotangent. So cotangent I know is cosine over sine, right? Plus sine. So over here, well, I'm going to end up with cosine squared over sine plus sine. And then we need to get common denominator. So I'm going to multiply by sine top and bottom. So I'm going to end up with cosine squared plus sine squared over sine. Well, this equals 1, so 1 over sine. So the inverse of this is cosecant. And that would be your answer. Okay? So this is simplifying. Okay? So I know it may seem kind of tough, but the more you practice it, the more verifying and simplifying will get easier for you. Okay?